Hi, I'm Lachlan Roche, and this project is our Smart Hazard Detection System developed for the Programming for Robotics course using the Embedded Intelligence WOCWI option. Our system is designed to monitor environmental conditions in real time using an ESP32 microcontroller, a DHT22 temperature and humidity sensor, and a HCSR04 ultrasonic sensor. The project follows a Sense2 process to decide to act robotics architecture model. Sensor data is processed through a finite state machine with 5 behavioral states: idle, survey, caution, emergency, and failsafe. Depending on environmental conditions, the system responds using adaptive behaviors including LED indicators, buzzer alerts, and servo motor scanning. In the following demonstration, we'll show the FSM behavior, like WOCWI simulation, and explain how the system uses adaptive monitoring and sensor fusion to respond to hazardous conditions.
Okay, so now I will demonstrate the live behavior of the system and how the finite state machine transition between different states based on the environmental conditions. So first we're gonna look at the ideal state. So as you can see, currently the system is operating in the ideal state where the temperature is around 25.3 degrees Celsius and the humidity is 50% at the moment. So the environment is considered safe. So the green LED remains active while the other outputs stay inactive. Moving on to the next one, we're gonna see the survey state. So for that I'm gonna reduce the distance. Okay, so as you can see now, when the ultrasonic sensor detects a nearby object, the system transitions into survey mode. In this state, the servo monitor scans the environment to simulate active hazard monitoring behavior. And at the bottom you can see the state is survey, as I said already. Now moving on to the next one, which is the caution state. So for that I'm gonna set the temperature around 50 degrees Celsius and I'm gonna reduce humidity to 30%. So now you can see that system enters the caution state because the warning threshold conditions have been exceeded. The yellow LED flashes, the buzzer activates periodically to warn nearby users of a potential hazard. So now we're gonna shift into the emergency state. For that I'm gonna increase the temperature around 65 degrees Celsius and I'm gonna reduce the humidity to 10%. So as you can see now, the system transitions into emergency state because both critical environmental conditions have been triggered simultaneously, and the red LED flashes rapidly and a buzzer becomes continuous to indicate a severe high risk situations. And moving on to the next and last state, we're gonna check the fail safe. So for that thing I need to remove one of our connections just to get that sense of failures. So I'm going to remove this connection and I'm going to start it again. So as you can see now, this demonstrates the fail-safe mode. So if in an invalid sensor readings or sensor failure like this happens, the system enters in restricted safe mode just to improve the robustness and the reliability of the system. And now we're gonna have a quick look to the code that what we have written down. And yep, so as you can see, this is our main file. So just to we're gonna go through with the all major functions and lines. So this is a function where this is in the section which defines the 5 as a finite state uh, machines which is used in this project. And going forward, gonna that's the sensors, and that's the one. So this is the update FM. This is the function who controls all state transactions using sensor fusion and the threshold based logic. And this is the thing, a sensor interval. So when the system also uses the adaptive monitoring intervals, so that in emergency conditions are monitored more frequently. And when I would say this one handles state outputs, so this function controls the LEDs, buzzer, and the servo behavior for each as FSM state. And so yeah, so to conclude this video, this project successfully demonstrates an embedded intelligent robotics system using the sense, think, act approach together with finite state machine control. And thank you for watching.